Progress on Research Project 1, Discovering the Origin of Eye Floaters. Okay, the studies that are designed to identify the origin of eye floaters are somewhat in arrest right now because of COVID-19. I'll describe the studies, but let me just share the logistics. I am a vitreoretinal surgeon. I conduct clinical research at the VMR Institute in Huntington Beach, California, which we've set up with specialized equipment and procedures to evaluate patients for various diseases, floaters being one of them. Any laboratory experiments that I've been involved with, and there have been many, and there are many going on right now, I do in collaboration with other institutions. And the question we're discussing right now, the origin, the etiology of floaters, has to be broached in different ways. And right now, the way that I'm approaching it is through collaboration with a scientist, actually a neurologist named Dr. Michael Harrington, who's at the Huntington Memorial Research Institute in Pasadena, California. And I've been working with him for a few years and his students. We also have a medical student from UCLA who's involved in this project. And there are 3 different things that we're doing with Dr. Harrington, all directed towards getting a better understanding of the etiology of floaters. The first is we're taking specimens that I remove at surgery from patients who have floaters, and more specifically, clinically significant floaters, which we call vision-degrading myodysopsia, or VDM. And we have done preliminary studies using a technique called dynamic light scattering to measure the average size of the particles in the material that I remove from these patients' eyes to cure their floaters, and have identified that there's an increase in number and an increase in size in the nanoparticles that we find in their vitreous as compared to a control group. But we have some statistical significance, but the numbers of specimens that have been studied are limited. The second, so we have to continue that, and I'll get to the reasons that hasn't taken off more rapidly in a moment. The second project is to test the hypothesis that, let me take a step back. When we don't really understand a disease, we tend to lump things together that really don't belong together. And in the context of VDM, what that means is that there's more than one cause for floaters. There's more than one etiology for the disease of vision-degrading myodysopsia. And as we learn more, we'll be able to subgroup these cases and perhaps design different treatments for different subgroups, depending upon what we find. So one subgroup of individuals who I think suffer from floaters because are due to a developmental abnormality. You've heard in my lectures of the past that during the first trimester of embryogenesis, the vitreous is filled with blood vessels. And by the end of the second trimester, the body has undergone a miraculous transformation where all of the blood vessels are eradicated, and the gel vitreous body is a clear, transparent substance. And there are many fascinating biological questions related to that transformation from a vascular tissue to an avascular tissue. But like any other biological phenomena, there's a bell-shaped curve, and there are people who don't undergo complete normal regression of the hyaloid vasculature, as it's called in the embryo. And I believe that the material that's left in an individual who has not undergone complete regression of the hyaloid embryonic vasculature lays the substrate for future problems with floaters. And I have published photographs of what that looks like. We can see structures within the vitreous body of an individual that have a branching pattern and that have a tubular appearance. And I think that you who suffer from these may recognize these glass noodle structures in vision that I believe are related to the embryonic vessels that have not undergone complete normal regression. So what we would like to do is take specimens from individuals who have undergone surgery and test them with immunohistochemistry in search of evidence that there are fetal vascular antigens. That's a challenging biological task, but that's the second set of experiments that we want to do at Huntington Memorial. The third addresses a different subgroup of people with floaters, and those tend to be older and are people who have experienced what's called a posterior vitreous detachment. When you're born, the vitreous is a solid clear gel and it's firmly adherent to the inside of the back of the eye. As you age, molecular changes occur that result simultaneously in the formation of fibrous aggregates within the vitreous body and liquefaction of the overall body. And it destabilizes the vitreous body so that when there is sufficient weakening of the interface between the posterior vitreous and the anterior retina, it collapses and it pulls away from the lining of the inside of the back of the eye, and it moves with head movement and eye movement. And because of its viscoelasticity, it has a damping effect and oscillations when coming to rest, experienced by all of us as floaters. The word floater comes from that viscoelastic property that causes the movement with head movement and eye movement after the vitreous has separated away from the retina in these individuals. Now, not everybody who gets a posterior vitreous detachment experiences bothersome and at times debilitating floaters. So why are some people bothered and others are not? Well, one theory is that when it pulls away from the retina, in some people it may not pull away cleanly. And there is some preliminary experimental evidence to suggest that it pulls pieces of the inner retina with it, and those remain adherent to the back surface of the vitreous body and interfere with the passage of light, creating shadows and the phenomenon of floaters, which when severe can be called vision degrading myodysopsia. So the experiment is to test that hypothesis by looking for antigens that are unique to the retina and not found in the vitreous. And more specifically, we are planning to look for type 4 collagen, which is found in the inner retina, but not found in the outer vitreous. And if we find elevated levels of type 4 collagen in the specimens that I've removed at surgery for individuals who have floaters and have a control group of people who do not have floaters, then we hope to test the hypothesis with that form of assay. So these three separate experiments are all designed to address the question of the etiology of floaters, and they're planned to be performed at the Huntington Memorial Research Institute laboratories of Dr. Harrington. Unfortunately, this past year has featured an interesting phenomenon in the history of man, that being the COVID-19 pandemic. And the Institute has been shut down for many months. It's beginning to open up, but access has been difficult. In fact, I haven't sent very many specimens at all during this past year. But that's also because I haven't had many cases this past year. There's a real problem going to arise, not so much for our concern, but in healthcare throughout the world, and that is that this year of postponed and delayed care is going to result in an increase in severity of various diseases like cancer and heart disease and other conditions because people have not been diagnosed promptly, they haven't been treated early, and they're presenting with late stages of disease. And we're beginning to see this in many different conditions. In our context, we haven't had many patients to operate on. We haven't sent many specimens, and we haven't had access to the laboratory to conduct these experiments. I'm told that it's loosening up and it's going to resolve, but other than very careful planning, as I've just described, we haven't really done very much experimentation at the present point in time to address the question of the etiology of floaters.